Across the central stretch of North America, the Great Lakes region is a place shrouded in myth and mysteries. Sometimes called inland seas, these 5 lakes, Huron, Ontario, Superior, Erie, and Michigan, hold over 1/5 of the world's surface freshwater. Their scale is staggering, with coastlines that run for thousands of miles, storms strong enough to mimic seas, and depths that could easily conceal pyramids. But beneath those blue waves is a world that no map or man can explain. From hidden rivers to lost DNA, these are the strangest things found at the Great Lakes. Number 15. Hidden rivers beneath the lakes. The Great Lakes aren't just open water. They sit atop one of the most complex hidden drainage networks on the continent. Seismic imaging and geological mapping have uncovered underground rivers and buried channels deep below the modern waterline. These are the leftovers of fierce glacial runoff, carved by floods from melting ice sheets thousands of years ago. Preserved in the bedrock, these hidden streams snake through ancient pathways, some of which likely influenced where humans and animals once migrated. Some researchers believe these ancient flows still affect the chemistry and balance of the lakes today, acting as unseen corridors for water and nutrients. These channels, now buried and silent, could hold untapped knowledge about the post-glacial world, shaping how we view the origin and evolution of the lakes. Their presence isn't just geological trivia, it's a reminder that what lies beneath the surface, invisible but active, continues to define the very nature of the Great Lakes themselves. Number 14. Remnants of primeval rainforests. Paleobotanists and palynologists are scientists who analyze fossilized pollen and plant traces, and they have detected clear signs of ancient forests in the Great Lakes sediment. Fossilized grains, leaf impressions, and petrified wood all suggest that, at various stages in deep time, lush, diverse forests blanketed this region. There were extended warm periods with high rainfall when fern-dominated ecosystems and hardwood canopies thrived, matching the biodiversity of present-day equatorial jungles. As climates shifted and tectonic forces dragged the region northward, much of this greenery was buried beneath layers of volcanic ash, glacial debris, and lake sediment. These fossilized remains preserve snapshots of big ecological shifts, volcanism, sudden droughts, and glacial invasions. Could understanding these ancient forests help us track how ecosystems collapse and rebuild? Their preserved record offers clues about life's fragility and resilience. Encoded in ancient pollen and charred wood is a past Earth that was alive with complexity, before climate and time reset the region into what we now call the Great Lakes. Number 13. Lake Michigan's hidden craters. Only with the help of high-powered sonar, researchers were able to detect a worrisome feature beneath Lake Michigan, around 40 massive craters spread across the lakebed. Their presence remained unseen by generations who crossed the waters above. These large pits appear totally out of place within the broad, flat landscapes of the Midwest. What kind of force could carve such deep impressions into the ground beneath these peaceful waters? Geologists studying the alignment and sediment around them propose that they date back to long past periods of geological violence. Theories range from meteor strikes by ancient celestial bodies to collapsed gas pockets or hydrothermal systems. Their exact origins are unknown, but they echo violent shifts in the landscape that happened before today's lakes even existed. The crater walls reveal layered sediments, each one a silent witness to an ancient world, some layers even older than the last ice age. What bones, plants, or secrets could still lie buried within those walls? Number 12. Shifting climate. The Great Lakes' new era. For generations, the Great Lakes region followed a recognizable seasonal rhythm, freezing, thawing, and rebirth. But recent climate data shows that these patterns are no longer consistent. Scientists now agree the lakes have entered a distinct new phase, where historical cycles can't predict what comes next. Accelerating ice loss, altered rainfall patterns, and warmer waters are reshaping the ecosystem. Algal blooms, changes in fish migration, and shoreline erosion are affecting everything from commercial fishing to agriculture to city infrastructure. The balance that defined this region for millennia is becoming harder to identify. Researchers think this shift gives a glimpse into larger planetary changes. The Great Lakes, once symbols of stability, are now among the most revealing indicators of climate disruption. What they're showing us is more than local. It's global. Understanding this evolving system isn't just science, it's survival. As nature redraws the lines, the lakes remind us that even inland giants can change, and with them, the world around us. Number 11. Chunks of lost continents. Buried deep within the most ancient rocks of the Great Lakes region, geologists have uncovered remnants of Earth's early crust, fragments of primordial continents. These mineral traces, identified in crystalline formations, carry distinct chemical markers that separate them from surrounding North American geology. Their composition reveals origins tied to supercontinents like Rodinia and Kenorland, which predate our current landmasses by billions of years. These pieces have endured colossal tectonic shifts and survived countless collisions, suggesting that the foundation of North America was stitched together from scattered remnants of the planet's earliest crust. Each mineral sample is a survivor of violent planetary reassembly, a preserved record of Earth's infancy. These continental shards offer more than historic interest. They challenge long-held models of continental formation. They show how much of Earth's structure remains hidden beneath familiar ground. The Great Lakes, it turns out, sit atop geological relics older than life itself. Beneath freshwater and sediment lies a map of Earth's deepest origins. Number 10. Lake Michigan's baffling geologic puzzle. The layers of rock beneath Lake Michigan tell a story geologists still can't fully decipher. Faults twist unpredictably. Circular depressions emerge in places they shouldn't. Seismic scans reveal collapsed zones, mineral oddities, and structural irregularities that don't align with standard geological models for this region. Some patterns hint at long-extinct volcanic events, while others point toward glacial pressure, sediment buildup, or crustal buckling. Fossil beds mixed with mineral streaks and traces of volcanic ash only deepen the uncertainty. Every drill core adds more details, but not clarity. The bedrock refuses to yield a single narrative. Instead, it presents a collision of geological episodes layered one atop the next. Some may trace back hundreds of millions of years. What formed the subsurface chaos beneath Lake Michigan? No single answer suffices. Each new investigation pulls at threads tied to ancient oceans, vanished mountain ranges, or buried rift zones. This isn't just a puzzle. It's a riddle written in stone and time. Number 9. Lake monsters and the fossil menagerie. Legends of lake monsters drift through the folklore of the Great Lakes. But what science has recovered from the region's fossil layers is no less extraordinary. Archaeological digs and sediment analysis have found bones and teeth from immense ancient animals, like mastodons and mammoths, along ancient shores, massive fish, armored sturgeons, and remnants of sharks from long-forgotten marine eras when this area was submerged under a vast inland sea. By tracking these discoveries, scientists are reconstructing vanished ecosystems that once teemed with life. Mammoths roamed the exposed lake beds during times of low water, while dire wolves and towering sloths stalked dense woodlands nearby. Layered fossils record how species adapted or vanished as climate shifted or environments collapsed. These fossilized remains are more than museum pieces. They reflect life's constant gamble between extinction and survival. Within these preserved bones lies the evidence of lost worlds, each reshaped by time, ice, and the relentless pulse of evolution through this shifting landscape. Now, let's move to Number 8. Archaeology below the ice. Recent advancements in underwater mapping have revealed clear signs of ancient human life in areas now submerged beneath the Great Lakes. Archaeologists have discovered stone tools, hearthstones, and remnants of campsites buried under lakebed sediments, evidence that early people once lived, hunted, and gathered along what were once exposed coastlines. These finds confirm that human settlement in the region dates back to times before the glaciers fully retreated. The water had not yet claimed the land. As meltwaters rose and flooded the valleys, these settlements were abandoned, preserved beneath layers of silt and clay. While many of these sites are still being explored, they are already helping researchers understand how early North Americans adapted to dramatic environmental changes. Each recovered artifact, whether a flint, a cooking stone, or charred remains, adds detail to a history long buried. These underwater sites are more than curiosities. They're chapters in the story we can't even understand. Number 7. Earthquakes in the least likely places. Despite its image as a calm and unmoving landscape, the Great Lakes region isn't immune to seismic activity. Seismologists have mapped fault lines reaching beneath the lakes, faults capable of producing tremors, albeit mild, even today. Core samples and sediment layers tell of more powerful ancient quakes that once shook this area with enough force to alter river paths, shift land masses, and possibly reshape parts of the shoreline. These events didn't leave behind ruins, but they did leave behind evidence: tilted sediment beds, broken rock formations, and displaced organic layers buried deep below. Are these faults now dormant, or are they still building pressure? The potential remains uncertain. But what's 100% clear is that the Great Lakes Basin has never been as geologically quiet as once believed. Beneath the still surface, tension lingers. These silent fault lines remind us that the Earth doesn't need mountains or volcanoes to shift. Sometimes even the most peaceful places carry the memory of violence. Number 6. The mystery of underwater stone circles. Imagine a diver's beam cutting through the murky green silence of Lake Michigan, landing on something that almost defies explanation. Stones set in what looks like a deliberate circular design, buried beneath the lake for thousands of years. While mentions of an underwater Stonehenge sometimes drift into myth, they're not entirely fiction. Sonar has revealed clusters of sizable stones under Lake Michigan that show clear, organized formations. Though their age and use are still being debated, some researchers suggest they may have served as hunting traps or landmarkers, built by prehistoric peoples when the lakebed was exposed and dry. One particular stone shows markings, possibly carvings, that some believe resemble an Ice Age animal like a mastodon. Though no solid conclusions have been drawn, these formations fuel real debate. Did ancient people leave them behind for a purpose now long forgotten? Or are they simply nature's coincidence? Their mystery continues, sealed under cold water and thick sediment. Number 5. Microbial oases. Life in extreme environments. Buried deep within Great Lakes sediments, far from light, oxygen, or warmth, are entire colonies of microbial life forms. Isolated in darkness, surviving off nutrients from decaying organic debris or ancient minerals, these extremophiles thrive in places once thought uninhabitable. What they reveal about survival pushes the limits of what we know. Some metabolize sulfur or methane, while others build communities across mineral crusts, adapting to freezing temperatures and long-term isolation. These tiny organisms offer scientists rare insight into Earth's earliest life conditions, environments that mirror the planet's ancient past. Studying their metabolism and genetic coding helps researchers build models not only for evolution here on Earth, but also for potential survival on other planets with similarly harsh conditions. Their significance goes beyond biology. They may hold keys for biotech innovation, resilience modeling, and ecological regeneration. These microscopic life forms, overlooked for centuries, now stand at the forefront of science, proving that even the smallest creatures can redefine what's possible and what's not. Number 4. Rare plants of the coastal dunes. Amid the constantly shifting dunes along the Great Lakes, botanists have documented a collection of rare and endemic plant species that exist nowhere else in North America. Among them are the pitcher's thistle, Lake Huron tansy, and the delicate dwarf lake iris, all uniquely adapted to these fire-prone, wind-scoured, and unstable sand environments. These species endure extreme temperature swings, limited nutrients, and constant environmental pressure from human development and invasive flora. Their existence traces back to post-glacial colonization, making them living relics of the last ice age. As habitats shift and coastlines erode, conservationists warn that these fragile ecosystems are becoming increasingly endangered. Studying these plants has revealed new insights into drought resistance, soil regeneration, and ecological adaptation. Their survival speaks volumes about resilience in harsh terrain. These dunes, often overlooked, are quietly home to some of the continent's rarest flora, holding tight to their ground, generation after generation, even as the landscape continues to shift beneath them. Number 3. New life in the islands, faunal advances. Scattered across the Great Lakes are thousands of islands, ranging from barren rock outcrops to fully forested wildlife havens. Many serve as vital sanctuaries for migratory birds, amphibians, rare reptiles, and small, isolated mammal populations. Conservation biologists monitoring these islands have observed the resurgence of native species like lake sturgeon, piping plovers, Blanding's turtles, and other sensitive fauna. The isolation provides a unique evolutionary buffer, offering protection from mainland predators and habitat disruption. Over time, these island environments have become testing grounds for restoration efforts, biodiversity studies, and population rebounds. With minimal human interference, several species have begun reclaiming lost ground, some even re-establishing previously vanished colonies. Each island offers a slightly different ecological snapshot, revealing how climate, geography, and isolation shape survival. These aren't just specks of land surrounded by freshwater. They're dynamic biological strongholds, quietly shaping comeback stories. In every nesting ground and shoreline, life continues, tougher, quieter, and more persistent than anyone expected. Number 2. Storms, shipwrecks, and the dance of destruction. Throughout history, the Great Lakes have seen storms as powerful as any oceanic tempest. Some have rivaled hurricanes in intensity, capable of toppling forests, shifting entire dune systems, and dragging fleets of ships to the lakebed. Shipwrecks, large and small, now rest silently beneath the surface, remnants of past disasters. Thousands of vessels have gone down in these waters, often during violent gales that struck without warning. Sediment cores and shoreline data reveal layers of storm debris, evidence of ancient weather events etched into the geological record. These layers aren't just historical, they're predictive, hinting at what future climate extremes could bring. With changing temperatures, storm intensity in the region is expected to increase. The Great Lakes have never been passive bodies of water. They shape coastlines, communities, and history itself. Every wrecked hull and shattered mast still resting below is a chapter written by the wind. These lakes don't just hold water, they hold tales carved in steel and storm. Number 1. The Flying Dutchman. While we don't know what's at the bottom of these Great Lakes, some stories refuse to sink. On a frigid November night in 1902, the SS Bannockburn disappeared without a trace on Lake Superior, taking all 21 crew members with her. No wreckage was ever found, but what followed cemented her Erie legacy. For decades, sailors have reported seeing the ship reappear during fierce winter storms, drifting through snow and fog, silent and untouched by time. Some even claim to spot skeletal figures standing on deck. The vessel came to be known as the Flying Dutchman of the Great Lakes, a ghost ship trapped in endless passage, never arriving, never vanishing completely. We hope you found this video interesting. If you did, be sure to like, share, and subscribe for more content like this. Thanks for giving us your time. We'll catch you soon.